Autophagy is often portrayed as a binary switch, on during fasting, off during feeding, but in reality, it functions more like a dimmer, finely tuned to the body's metabolic environment. While it's true that fasting strongly activates autophagy by lowering insulin and mTOR activity, certain types of food, particularly complex carbohydrates rich in polyphenol and fiber, can help sustain a gentle, rhythmic autophagic response even in the fed state. This subtle modulation is less about starvation and more about harmony, supporting the body's repair systems while still providing nourishment and energy stability. In this nuanced context, foods like sweet potatoes, oats, buckwheat, and legumes play a powerful, often underestimated role in extending the life and function of autophagy beyond the fasting window. What sets these complex carbohydrates apart is not only their slow digestion and low glycemic impact, but their rich content of bioactive compounds that interact with cellular stress pathways. Unlike refined sugars that flood the bloodstream and spike insulin, complex carbs digest gradually, releasing glucose in a controlled manner. This promotes stable insulin levels, keeping mTOR activity low enough to allow for intermittent autophagy between meals. These post-meal dips, small metabolic valleys where insulin remains low and energy balance slightly tips, are brief but biologically meaningful, giving cells an opportunity to resume mild cleanup rather than shifting fully into storage or growth mode. Even more fascinating is the role of polyphenol, the naturally occurring plant compounds found abundantly in many complex carb sources. These include anthocyanins in purple sweet potatoes, avenanthramides in oats, and tannins in lentils and beans. Polyphenol exert a hormetic effect. They mildly stress cells in a beneficial way, triggering adaptive responses that include upregulation of antioxidant defenses and activation of autophagy-related genes. In this way, certain complex carbs act as metabolic educators, nudging cells toward resilience without the harshness of complete nutrient deprivation. They also stimulate the production of endogenous antioxidants like glutathione, which reduce oxidative stress and protect mitochondria, an organelle whose health is closely tied to the regulation of mitophagy, the autophagic process that clears dysfunctional mitochondria. Fiber, another key component of complex carbohydrates, further supports this rhythm of autophagy. Soluble fiber and resistant starch are fermented in the gut to produce short-chain fatty acids, SCFAs, particularly butyrate. Butyrate, as discussed in gut health research, is more than a fuel for colon cells. It's an epigenetic regulator that promotes autophagy, especially in intestinal and hepatic tissues. It activates AMPK, downregulates inflammatory signaling, and supports tight junction integrity in the gut, reducing systemic inflammation and supporting immune modulation. These effects feed into a larger feedback loop where the gut informs the rest of the body of its metabolic status, and when the gut is thriving, autophagic tone tends to remain balanced across other systems as well. What emerges from this synergy is a concept of metabolic buffering, where complex carbohydrates do not shut down autophagy but cushion it, keeping the system from swinging too far into either neglect or excess. In practical terms, this means someone who breaks a fast with a bowl of oats topped with nuts and berries might still maintain partial autophagic activity while benefiting from glucose replenishment and micronutrient delivery. This rhythmic modulation of autophagy may be especially beneficial in populations for whom long fasts are unsustainable, such as those with high energy demands, chronic stress, or certain hormonal imbalances. It's a way to support cellular cleaning without denying fuel, a nutritional middle ground between feast and fast. Moreover, complex carbs contribute to circadian alignment. Many of them contain small amounts of tryptophan and magnesium, both of which support melatonin production and parasympathetic activity at night. Eating these carbs earlier in the day or as part of a balanced dinner can improve sleep quality, which in turn supports the nightly surge in autophagy that occurs during slow-wave sleep. Sleep and autophagy are deeply interconnected, and the right carbohydrates can nourish this relationship, not disrupt it. In this light, complex carbohydrates are redefined not as autophagy antagonists, but as intelligent modulators, nutrients that can extend the window of cellular maintenance while also fueling the body and brain. Far from being obstacles to longevity, they become tools of metabolic finesse, offering a way to eat for energy without switching off the mechanisms that keep us young. When chosen wisely and consumed mindfully, they bridge the divide between nourishment and renewal, proving that the path to cellular health doesn't have to be paved in hunger, but in harmony.